Okay, we are still continuing the Math 4 exam review, and we're now on problem 16D, which is asking us for the fifth root of negative 243 x to the sixth y. So that means we're looking for, under our radical sign, 5 identical factors because we're taking a fifth root. So you can see right away with the y, I don't have 5 identical factors, and we know before we even start that the y is still going to be under the radical sign because anything that doesn't have 5 identical factors can't take a fifth root. So now, the first thing we want to decide is, can I take a fifth root of a negative number, or am I going to need to go into imaginary number mode and take out an I for that negative? Well, a fifth root is an odd root, and an odd number of negatives multiplies to a negative, so I can do that. I can take a fifth root of a negative, so that part's not going to be a problem. So next I've got to figure out if there are 5 identical factors in negative 243, and the first thing that comes to my mind is 3, and 243 is the fifth multiple of 3. So I can rewrite that so far as the fifth root of negative 3 to the fifth power. If you're not sure about that, check it in your calculator. Negative 3 raised to the fifth power is negative 243. And remember, on our exponents, the rule is it has to be divisible by 5 because 5 of them make a fifth root. 5 x's, or x to the fifth, would be the fifth root of x to the fifth, would just be x. So I have a 6, so what I want to do is rewrite that so that my x is a multiple of 5 in the leftovers. So I'm going to make that x to the fifth x, and then just y, because there is nothing else there. We know we're not going to be able to take that one. So when I take the fifth root of negative 3 to the fifth power, I get negative 3. When I take the fifth root of x to the fifth, remember the rule is 5 divided by 5 is 1, so that's x to the first power, but we don't need to put the 1 there. And then the x and the y, I can't take the fifth root, there's only 1 each of those, so I just rewrite those under my radical, and that's xy. And so the fifth root of all of that, I took out what I could. I took what I could take the fifth root of, and I got negative 3x as the fifth root of negative 3 to the fifth, x to the fifth, and xy stayed under the radical sign. So that's my final answer. Okay, for E, I'm taking the opposite of, or the negative of, the square root of 252, x to the sixth, y to the 15th. Well, I know right away off the top of my head that 252 is not a perfect square, and that means I'm not going to be able to just take the square root of it like I did over here. So since I don't know a single number multiplied by something that would give me a square root of that, I'm going to prime factor that, and that'll help me decide if I have any doubles or sets of roots under there. So when I prime factor that, I got 2 times 2 times 3 times 3 times 7. If you're not sure, use whatever method you use to prime factor, and then see if you don't get those same numbers that I did. X to the sixth is okay because I'm taking the square root, and 6 is a multiple of 2, so that's x to the sixth. And y to the 15th, since 15 is not a multiple of 2, I want to rewrite that as y to the 14th, y. That adds up to 15, and 14 is a multiple of 2. So now remember, on the numbers, we're looking for 2 identical factors. I have 2 identical factors here and 2 identical factors there. So that means this is 4 and this is 9. The square root of 4 is 2, so I'm going to take out a 2. The square root of 9 is 3, so I'm going to take out a 3. So I'm going to go ahead and cross those out because I've used them, since I'm going to have some things left here. I don't want to get confused. X to the sixth is a perfect square. 6 divided by 2 is 3, so I have x cubed. We'll get rid of that one too. Y to the 14th is 14 divided by 2 is 7, so I have y to the 7th. Used that. So I go back and write my radical, and what's left underneath there that I didn't use is a 7 and a y. Do you think I'm finished yet? The answer to that is no, because I still need to multiply my 2 and my 3 over here. So that becomes negative 6 x cubed y to the 7th times the square root of 7y. And there you go. That should be the answer to it. That negative outside did not affect anything I was doing in here because I was saying the negative or the opposite of what I got when I took that. So the negative just stays out front. Whereas here I had a negative under a radical and I had to decide whether I was going to end up with an imaginary answer or whether I could take the fifth root of the negative. If this had been an even root, I would have had to take out an I for the square root of -1, but because it was an odd root, I was able to take the root with a negative underneath there. Okay, moving on to F, I have the 7th root of q to the 38th, r to the 142nd, s to the 14th. Remember the rule here, since I don't have any numbers to find out if I have a 7th root of, these need to be multiples of 7 for me to be able to take the root. I'm looking for 7 identical factors. So I'm going to rewrite this as the 7th root, and I'm going to make those numbers multiples of 7 and their leftovers. So that's going to be q, and I'm looking for the closest multiple of 7 that's near 38, and that's going to be q to the 35th, because 35 is divisible by 7, and then I'm going to have 3 left over, q cubed. R to the 142nd is going to be r to the 140th, because 140 is a multiple of 7 with 2 left over, r squared. And then 14 is a multiple of 7, so I just have to have s to the 14th. Let's extend my radical there. So 35 divided by 7 is 5, so q to the 5 comes out. R to the 140th is a multiple of 7. 140 divided by 7 is 20, so I have r to the 20th. Let's get rid of that one we used and get rid of that one we used. S to the 14th, 14 is a multiple of 7, it goes in 2 times, so that's s squared. I used that. What's left under my radical sign is q cubed, because 3 is not divisible by 7, and r squared. And that's my final answer. Okay, number 17 asks us to find the exact distance between the 2 points and write our answers in simplest radical form. I've written the distance formula there. Remember, you do have to have that memorized for the exam. I won't be giving it to you. So for 17a, our distance is equal to the square root of, and it's x2 minus x1. I'm going to call this x2, so it's -21 minus -5, which is +5, squared, plus 21 minus 9 squared. That gives us the square root of -16 squared plus 12 squared, which is the square root of, I'm just squaring both of those, 256 plus 144. Add those two together and you get 400, and the square root of 400 is 20. So that means the distance between those 2 points is going to be 20 units. And I think we'll move on to B on the next tape because we're about out of time here.